Hello everyone, welcome back to Electric Circuit Theory. Myself Mr. D. Rajendra. Today our topic of discussion is types of electrical elements. So as you see, there are 5 types of elements, right? First one, active and passive elements. Second one, linear and non-linear elements. Third one, bilateral and unilateral elements. Fourth one, time varying and time invariant elements. Fifth one, lumped and distributed elements. So we will see one by one these types of electrical elements. Okay, the first one is active and passive elements. This is the one of the very important topic. Okay, so when an element is said to be active, when an element is said to be passive, you should know these two definitions. Okay, now, so an element is said to be active element which will deliver energy for long time, then those elements are called active elements. Okay, suppose if you take our voltage source and current source, they will deliver energy to the circuit for longer time. Okay, so those elements are called active elements. What is the definition? Elements which will deliver energy for longer time, then those elements are called active elements. Okay, otherwise, what is otherwise means? Elements delivering for smaller time. Okay, elements deliver energy for smaller time, those are called passive elements. So examples, inductor and capacitor. So when inductor and capacitors are energized, okay, when they have initial energy, then they will deliver energy, okay, but not longer time, very small duration. Okay, very small duration, maybe in order of milliseconds to microseconds. Okay, those are called passive elements. Understand? The basic definition of active and passive is elements which will deliver energy for longer period, those are called active elements, otherwise passive elements. Okay, so what are the examples of active elements? Our voltage source and current source are the examples of passive elements. What about, voltage source and current source are the examples of active elements. Then resistor, inductor, capacitor, okay, these are called passive elements because they won't deliver energy for longer time. Now I will give one condition to check whether the element is active or passive. What is that condition? Energy delivered for longer time. You need to check the condition. What is that condition? If the element is delivering energy for longer time, then you can call as a active element. Or other condition is internal amplifying nature. The element having internal amplifying nature, then that type of elements are called active elements. Okay, what are those? Those are active elements. What are those? Your amplifier, BJT, MOS transistor, these are called amplifier active elements. Okay, after knowing what is active and passive elements, I will give some definition, some examples for active elements and passive elements. So our voltage source and current source are the examples of active elements because they will deliver energy for longer time. Okay, maybe in terms of hours or days or years also. Okay, now BJT and op-amp, these two are out of course, out of the syllabus, but these are also called active elements. Okay, now what about passive elements? Passive elements are resistor, inductor and capacitor. Okay, resistor always dissipates energy in the form of heat. Then inductor and capacitor, when they have initial energy, then they will deliver the energy for the circuit very small duration. Okay, maybe in micro to milliseconds. Okay, very small duration. And antenna is also called a passive element. So this is a list of examples for both active and passive elements. Clear? Yes. Second one, linear and non-linear elements. So what is linear element? What is non-linear element? We will see one by one. So an element is said to be linear element, then its VI characteristics should be passing through origin. Okay, let me assume a plot between voltage and current. So this is, assume it's a current and it is voltage. If the plot between I and V is passing through origin for an element, this is the plot between voltage and current, then you can say that element is linear element. Okay, that element is linear element. Okay, VI characteristics are passing through origin, then you can say the element is linear element, otherwise non-linear. Simple, right? So here, what is the condition? IV plot line passing through origin, then you can say that element is linear element. Okay, or some other condition also, when elements are obeying Ohm's law, then you can say it is linear. So elements which obeys Ohm's law and IV plot will be passing through origin are called linear elements, otherwise non-linear. Okay, simple. If something is true, then that is linear, otherwise non-linear. What is that something? This is the condition. IV plot flowing through origin, then that is called linear element, otherwise non-linear element. What are the examples of linear elements? Our passive elements are the examples of linear elements. Both RLC components, okay? Resistor, inductor, capacitor are the examples of linear elements, okay? Diode, then BJT, op-amp, all these are non-linear elements, okay? Third one, bilateral and unilateral elements, okay? So an element is said to be bilateral, then impedance offered by the element is same in both directions. Let us take an element, okay? Let us take a resistor. So it has two terminals, P and Q, okay? Now if I apply current, if I apply current through P, okay, I am applying current through P, then voltage will be developed like this, okay? Less on the P side, minus on the Q side. Then plot IV plot, okay? Plot between I and V. You will get this kind of relation. Okay, I am calling this is the first condition. So you will get this condition. Okay, let me mark this as current I. This is V. Okay. Now in the second condition, I will apply current from P. Okay, I will apply current. I apply current from P. Then voltage will be developed like this. Okay. This is plus and this is minus. Now plot between I and V. You will get same plot as this one. Now if I take the plot between I and V, you will get these two waveforms. Okay, if you see these two waveforms, both are exactly same, right? That means impedance offered by the element in the both cases, when you apply current from other terminal to some other terminal, you will get the same plot. Okay, those elements are called bilateral elements. Okay, bilateral elements. Now what are the examples of bilateral elements? Our passive elements. Okay, resistor, inductor, capacitor are the examples of bilateral elements. Okay. Now, what about unilateral elements? If the IV plot is different for both directions, then you can say that is unilateral elements. What are the examples of unilateral elements? Our control sources. Okay. Control sources. So, what are those control sources? 4 types, right? Voltage control, voltage source, voltage control, current source, current control, voltage source, current control, current source. So these are the 4 types belongs to unilateral elements. Okay, these are the 4 types belongs to unilateral elements. Okay, the 4th category is time varying and time invariant elements. Now, if the IV plot depends on the time, then that is called, if the IV plot of an element is independent of time, then that is called time invariant element. Okay. Now if you see in the plot, for time t1, this is the IV plot. Okay. This is the IV plot for time t1. Okay. Now for some other time, plot is changing like this. Okay. That means for different values of time, we are getting different IV plot. So this kind of IV plot characteristics are there for an element. That element you can call as a time varying element. Okay, with respect to time, the plot is varying. Okay, this is called time varying and time invariant elements. The last one, lumped and distributed elements. Okay, so what is the definition of lumped elements and distributed elements? Means the characteristics of an element exists in a particular point, then that is called lumped elements. Now the characteristics of an element exist for a longer length or entire length. If the characteristics of an element exists entire length, then those elements are called distributed elements. Okay. Now here if you see our resistor, inductor, capacitor, these 3 having the property. Okay, the characteristics will be existed between only some point. Between those 2 points, we have the inductance property or capacitance property or inductance property. Then those elements are called lumped elements. Okay. What about distributed elements? Our transmission lines. If you see conductors, right, roadside you have some conductors. Those things are called distributed elements. Okay. So the characteristics will be distributed along the length of the wire. Okay, whatever the length, maybe it's 2 kilometers, 20 kilometers, but the properties will be distributed along the line. Okay, along the wire. Those are called distributed elements. Okay. So RLCG, resistor, inductor, capacitor, and conductance are the examples of lumped elements. Now transmission lines are the examples of distributed elements. Okay, what is the summary of our today's lesson? So we have seen 5 categories of circuit elements. What are those? Active and passive elements, linear and non-linear elements, bilateral and unilateral elements, time varying and time invariant elements, lumped and distributed elements, and the examples. Okay, we have seen 5 topics. Okay, 5 types of circuit elements. Okay, now we are going to discuss our second topic, types of sources. Okay, so this is very important. So there are 2 types of sources, 2 types of energy sources. First one, dependent sources. First one, dependent sources. Second one, independent sources. Okay, so independent sources, again 4 types: ideal voltage source, practical voltage source, ideal current source, practical current source. Okay, so there are 4 types of independent sources. Okay, so dependent sources are also 4 types: voltage controlled voltage source, voltage controlled current source, current controlled voltage source, current controlled current source. So there are 4 types. So we will discuss one by one what are these sources, what are the IV plots for these sources, then how these sources will behave. Okay. First we will see about independent sources. The first element in independent sources is ideal voltage source. Okay, what is this ideal voltage source? The source which deliver constant voltage to the load. Okay, an element which deliver constant voltage to the source, to the load, then that is called ideal voltage source. So what is the symbol of ideal voltage source? This is the symbol of ideal voltage source. So this is the symbol of ideal voltage source. Now how to represent voltage source? With the polarities plus and minus. So this is the voltage source. Okay. Now, so internal resistance of ideal voltage source is 0. So here you can assume a resistor value is 0 ohm. Okay. So this is very important. What is the internal resistance of ideal voltage source? It is 0. Okay. So current flowing through this ideal voltage source can be anything. Okay, it can be any value. It may be 0, it may be positive, it may be negative. Okay. So we cannot say current flowing through the voltage source value. Okay. What is the current flowing through voltage source? It may be anything. We cannot say. Okay. It's depending on the circuit configuration. Okay. Next, what is the plot of voltage source, ideal voltage source? This is the plot of ideal voltage source. Okay. Now, whatever may be the current, voltage is constant. So if I plot IV characteristics for ideal voltage source, it is look like this. It is some value, let us assume V0 for 0 current. For 1 ampere current, it is constant. It is constant only. For 2 ampere, it is also constant. So whatever may be the current is changing, but voltage is constant at V0 only. Okay. Whatever may be the current is 1 ampere, 2 ampere or 1.2 ampere, that is not matter. Voltage is constant with respect to all currents. Okay, that is the meaning of ideal voltage source. Okay, so ideal voltage source maintains constant voltage with respect to time. Okay, it may be negative also. This is the meaning. For negative current, voltage is constant only, V0. Okay, V0 may be any number. V0 may be 1 volt or 2 volt or minus 2 volt, something. Okay, it is a constant value with respect to current flowing through the voltage source. Okay, so next one, practical current source. So which is the very minute modification to the ideal voltage source. Okay, what is the modification? Then what is the IV plot? We will see now. Practical voltage source is a voltage source. It will deliver constant voltage to the load. Okay, now, so what is the difference between ideal voltage source and practical voltage source? What is the difference means? It has internal resistance. Okay, very small modification to the ideal voltage source. So it has voltage source in series with a resistance, okay, very small, maybe in the order of 100 ohm, okay, 100 ohm or 10 to 100 ohm only, okay. So this is the symbol of practical voltage source. A voltage source series with a resistance is called practical voltage source. Okay, a voltage source, some value, let us assume V0 and some resistance value Rs. Okay, so this is the symbol of practical voltage source. Okay, now due to this Rs, so some part of voltage will be dropped across this Rs. Okay, so that is why the plot will be decreased. Okay, decreased towards I. If you see this graph, if you see this ideal graph, IV plot, okay, if you see this plot, this is expected, okay, this dotted line will be the expected value, but due to this presence of this internal resistance value, voltage will be dropped, okay, so voltage will be decreased, this is called decreasing, okay, this is due to the internal resistance of ideal practical voltage source. So as current is increasing, then this value will be decreases, okay, so this is what practical voltage source IV plot. Okay. Similarly, as I told in the previous, what is the current flowing through voltage source? We cannot say. Okay. It may be positive, it may be negative, it may be zero also. Okay. So it can be determined from the circuit. Okay. We cannot say orally. Okay. In general, if you go to any market and find voltage source, it will be costlier than our passive elements. Okay. So passive elements are somewhat costlier than our active elements are somewhat costlier than our passive elements. So if you go to any market and find voltage source or current source, they are very costlier than passive elements because it will deliver energy for longer time. Okay. So these are very costlier than passive elements. So that is about voltage sources. Now we will discuss about ideal current sources. Okay. So what is ideal current source? What is the plot of IV current source? Then what is the internal resistance of ideal current source? We will discuss now. So what is this ideal current source? This is an element will deliver energy, deliver constant current to the load. Okay, for load it will deliver the constant current. Then irrespective of load voltage. Okay, whatever may be the load voltage, it will deliver the constant current. Then what is the internal resistance of ideal current source? That is infinity ohm. So it has resistance very large value. Here it will be infinite. Okay, very large value. So internal resistance of ideal current source is infinite. Okay, ideally it is infinite. Now what is the plot of IV characteristics of this current source? Ideal current source IV plot is look like this. So this is the plot. Okay. Now whatever may be the voltage, it may be 0.1 volt or 0.2 volt or 0.3 volt. Current is constant. Okay, it is some number. It may be constant for negative voltage also, minus 0.1 volt. Current is constant only. Okay. This IS may be 1 volt, 0.1 volt, minus 1 volt, 1 ampere, minus 1 ampere, minus 2 ampere. Okay. It may be positive or negative for all the voltages. Okay. It is constant. First of all, this is constant and it may be a positive number or negative number. Similarly, practical voltage source, we have practical current source. So this is also derived from ideal voltage source. Okay. So what is the modification to the practical current source? Very small modification. What is that? It has a large internal resistance. Okay. It has a large internal resistance. What is the purpose of this practical current source? It will deliver constant current to the load irrespective of load voltage. Okay. Previous thing only. But what is the modification? Modification is it has a parallel resistance. What is the value? It may be in mega ohm. Okay, very large value. Practically, this value is very large. Okay, in terms of mega ohm. So, what is the internal resistance of ideal current source? Practical current source. Practical current source has an internal resistance of mega ohm. Okay, mega ohm. Very large value. Okay. Now, due to this resistance, current will decrease. Okay, this is ideal. This is our ideal plot. Okay, constant with respect to voltage, but due to the presence of this resistance, our current is decreased. Okay, somewhat. Okay, this is decreased. How much it is? Voltage by current value. Okay, voltage by current. Sorry, voltage by resistance value. That much current will decrease. So that is about independent sources. Independent sources are 4 types. So ideal voltage source, practical voltage source, ideal current source, and practical current source. Okay. So we have seen 4 types of independent sources. Now we are going to discuss dependent sources or control sources. Okay. Both are same. Dependent sources or control sources, both are same. So these are represented by symbol called So to represent dependent source or control source, we will use this symbol, okay, diamond shape symbol. Okay. So as I discussed, there are 4 types. Voltage controlled voltage source, first type. Voltage controlled current source, current controlled voltage source, current controlled current source. So there are 4 types of dependent sources. Clear? There are 4 types of dependent sources. Sometimes we can call as a control sources also. Okay. We will see these things one by one. Okay, first one, voltage controlled voltage source. So this is the symbol. First of all, you should understand what is the symbol, what is the value. Okay. Now, what is the source? Voltage source. VCCS. VCVS means voltage controlled voltage source. First of all, this is the voltage source. So dependent source, right? So write down this diamond shape symbol. Then mark plus and minus. So if you see plus and minus, you can identify this is a voltage source. Understand? This is a voltage source. What is the value of this voltage source? K times Vx. Okay? K times Vx. So voltage control voltage source. Voltage control voltage source means this is the symbol. This is a diamond shape symbol. Plus minus some voltage. Some voltage, that is K times Vx. Okay? Now this is the voltage source. What is the value? Value of the voltage source is K times Vx. Okay. Now, what is this Vx? Vx is called controlling parameter. Vx is called controlling parameter. If I change this Vx value, then this source value will change. Understand? What is this Vx? Vx is a voltage between somewhere. Okay, let us assume this is a voltage Vx. Between 2 points. Okay, let me mark some points A and B. Okay, A and B is a 2 points where voltage is Vx. Okay, if I change this voltage, this source value will change. Okay, that means value of this source depends on some other voltage. Okay, understand? I will give an example now. Now in this circuit diagram, there are independent sources and dependent sources. So what is the independent source? 7 volt source is the independent source. Now what is the dependent source? Voltage controlled voltage source. So this value how much? 2 times Vx. This Vx is measured between this 4 ohm resistor. Okay. Now if this voltage is changed, then this value will change, right? This value will change. That means this voltage value depends on some other voltage. That is called voltage controlled voltage source. Okay. The meaning of voltage controlled voltage source is voltage of the source will depends on some other voltage. That some other voltage will be present in the circuit. Okay. Somewhere that voltage will be defined. This is called voltage controlled voltage source. Okay. This is a dependent source. Okay. Here, so this voltage controlled voltage source is linear. Okay, because IV plot will be like this. So here some voltage V1 and here K times V1 Vx. So this is the plot for this voltage source and it is unilateral elements. Okay. Next one, where K, this K is a unitless quantity. Okay, in general it is called gain. That is about voltage control voltage source. Now voltage control current source. So first of all, what is the source? Current source. So current source means it has a arrow direction, right? Arrow from top to bottom or bottom to top. Now this is the symbol of voltage control current source. Now this is a current source. Value of this current source is this one. Value of this current source is this one. This is the current source value. Now what is this G? This G is called conductance. The what is this Vx? Vx is called voltage. Okay. So if I vary this voltage, this source value will change like previous. Okay. Now previous we have seen so this is the exact symbol of voltage control current source. Okay. Now between points A and B we have voltage Vx. This voltage will be controlled by this source. Okay. So when I change this Vx value, the source entire value will change. Okay. So this is about voltage control current source. Okay. Remaining two are current control voltage source. Okay. Current control voltage source. So first of all it is a current source. Value is a depends on some other current. Okay. R into Ix. These are all are linear and unilateral elements. So what is this R? R is called resistance. Okay. It has units of ohm. Then what about this current control current source? So this is a current source. Value depends on some other current. Okay. Okay. This is where K is called gain. It has no units. So this is about our dependent sources.